I am embarrassed
Already?
already. I'll explain why in a few minutes. Last year, we talked about the table reorg utility, which is new in version 12. And this year, we're going to talk about that again, because we have more interesting stuff.
And we didn't do it right last year.
We didn't?
No.
Well, we also came up with some unexplained behaviors that led to some questions, which we can provide answers for this time. So, anyway, we have basically two topics to share with you. One is just some basic how to use table reorg, and then Mike is going to give you some advanced topics on more sophisticated things you can do.
So for the front half of this, I'm just eye candy, so I'm just going to sit down.
All right. So the secret bunker is a long-standing tradition at these conferences. We did the first one in 2002, where we were evaluating the Progress database performance on Linux, which was uncommon at the time. And here is our original benchmark laboratory. The facilities we had were somewhat primitive. This was John Harlow's garage. So this year, the secret bunker is in a different location. This is the same bunker we used last year. We have to use the same bunker because we're talking about the same utility.
Yeah.
So, last year we talked about dump and load optimization, and this was the first time that we had used the table reorg utility. So we talked about that. And this year, we're going to revisit some of last year, and then we're going to have the advanced topics. So the basics of table reorg are pretty straightforward. Here's the test machine that we used for these experiments, same as last year. It's actually a pretty stout machine, which cost me $600 a few years ago. If you know what the Furgal test is, the Furgal time on this machine was less than half a second, which is really fast for a primitive machine from 20 years ago. Okay, so why do we need the table reorg utility? Well, two things. Make the physical storage order match index order. I'll explain how that matters in a minute. And the other is to reduce or eliminate record fragmentation. When you have large records that don't fit in a block, they have to be fragmented. But sometimes you get fragmentation of small records that would fit in a block, but because of the way the space gets allocated, they end up becoming fragmented, or the update causes them to fragment after they've been created. And the table reorg can eliminate that type of fragmentation. So, a reminder of what a row ID is. A row ID is a unique number which tells you where in a storage area a record is located. It's an identifier for a record, and you can use that identifier to calculate where the record is, and then you can go retrieve it. Now, an index also tells you where a record is. So you can look up a key value, find the associated row ID, and go retrieve the record. Here's an example. We have a character index, city name, and then the row IDs for those records. And you can see here, there's one order for the indexes, and the row IDs are randomly scattered. So they're all over the place. So what that means is, when you go read those records, you're going to be searching all over the disk if you do a for each on this index. But you can fix that so that the index order and the row ID order match. So now we have row IDs in increasing order, same as the key values are. So that's what table reorg does, is makes those two things match.
Like a dump and load.
Yeah. Why do I care? Why do you care? Because when you have this order, that causes seeks all over the disk, so it performs more slowly, sometimes a lot more slowly.
And less likely to be in the buffer pool.
Yeah. So if you're for eaching on this index, you're going through row IDs that are in the same order. Not only are you eliminating seeks, but you're also getting blocks that have multiple records in them. So you read a block, it's got maybe 10 records that you wanted all together, so you're reducing the amount of I/O for that operation. Now, unfortunately, the physical order can only match one index. So the other indexes won't have this same property. All right, so here's the documentation for the table reorg utility, and you can see that it has a lot of options. So it's pretty flexible. So you can choose what you want to reorganize, and a variety of options. So you don't have to reorganize a whole table. You can pick just some of the indexes and reorganize those. I don't know why you'd want to do that, but you can. Okay, so why am I embarrassed? Well, last year, I
Me too.
had a test database which was built with these characteristics. And I made the statement that this was a fresh database, hadn't been used, so the account numbers matched the row IDs for this table. That's not true. So that was a lie. An accidental one, because I'd built this database so many times over the years, I didn't even think about it. I just built it. I picked the size I wanted and built it. The reason that it came out wrong is because there's 4GL code that creates the records in this table, and normally we run multiple load processes at the same time to populate this table. So it'll load faster, so if you're making a big one, it won't take 3 days. So that multiple loaders take the account numbers and divide it up into ranges, and they run in parallel, so you end up with the count numbers all mixed together by the different load processes. So the index doesn't match the row ID. So now when you run table reorg on this, it shouldn't do anything, because all the records are in the right order already. So reorganizing an already organized table shouldn't happen.
So that solves mystery 1 from last year.
That's right. So, so the first test we ran, the database doubled in size because all the records got moved. Even though I maintained, well, something's strange here because the records don't need to be moved. They're already in the right order, except they weren't, but I didn't know that. So we got this result, which is not correct. So, so this is what happened, and everything in this red box is wrong.
Well, it was still a database.
Well, yes.
It is still reorged. It just wasn't it wasn't set up the way we thought.
Right. But so the point is, so I'm standing here telling you things that just aren't true. So that's why I'm embarrassed. So now, this year, when I built that database, I used a single load process, and it actually ended up being properly ordered. So the index order and the row ID order matched. So when you run table reorg on it now, you get this result. And also an enhancement that was made sometime during 12. Last year we used 12.3, and this year we're using a newer release. And so it put out this message that said 0 records were processed. That's an enhancement that wasn't there in last year's version. So it's telling us 0 records processed, which is what we wanted or expected. Then the other thing is, if you reorg again on the same database, the one that you just reorged, you got this result last year, which is also not correct, or not what we expected. Because again, you're reorganizing something that's already organized, so why is it working so hard and doing stuff when it doesn't need to? So this year, when you do that, you get this result. So if you reorg and then reorg again, this is what happens, which is what it's supposed to. All right. So that explains why I'm embarrassed. Now, I did some further tests this year just to see if I got anything interesting with the newer version. So I made a bigger database. This one ended up being 14 gigabytes instead of 1.4, which the first one was. Okay, and for this one, I let it run with the multiple loader processes, so it's only partially ordered. It's not a clean database. So in this case, we have 3 million or so blocks in the account area, and 92% space utilization and no fragmentation. So if we reorg that, we get this result. It takes 65 minutes, roughly, to do the reorg, and the database grows quite a bit because all the records have to be moved. And in the initial setup, all of the account area clusters are all filled up. So when it's reorganizing the records, it's got to allocate new clusters and put the records into the empty space that it's got. And it can reuse some of the original clusters once they've been emptied, but because the records are not properly ordered, it takes a long time for those things to get emptied. So the database grows. So in this case, it grew by 2 million blocks. And then we end up no fragmentation, but only 60% utilization because all the original locations for the records. That space is now free, so it's not being utilized. So we go from 92 to 60 because of that. And then if you run the same test a second time, now when it's reorging a reorg database, you get 0 records processed, which is what you're supposed to get. So there was something else that was causing extra work when you did the second reorg, which changed between last year's version and this year's version. But since I don't have access to the bug database, I can't go look and see what that was. Question?
Which version did you use this year?
It's 12.8 alpha. I thought it was the final 12.8, but I accidentally installed the alpha version, not realizing that it was the alpha because I labeled it wrong. Okay, next scenario, we make the records different sizes. In the ones I just talked about, the records are a little over 100 bytes long, so they're uniformly almost all the same size. So I took this database and modified it so that the record sizes varied. So I took the database that got built and ran 4GL code that updated the records to make them bigger by various amounts. So I'd used the random number generator to pick the size. So now we have a 40 gigabyte database with much bigger records, and they're all different sizes. So it's more like a actual real-world database. Not exactly, but at least it's more realistic than what I started with. So we have 2 million blocks on the RM chain. Lots of fragmentation, 192 million fragments. And 95% space utilization. So it's pretty tightly packed, but there's lots of pieces. So what happens when we reorg that? That took 86 minutes, and the database grew from 40 to 46 gigabytes. So it didn't grow by the same proportion as the earlier, smaller database did. This one grew by 6 gigabytes roughly. So 2 million more blocks. Now we end up no fragmentation because the biggest record is 1,500 bytes. So there aren't any records that won't fit in a block. So it eliminated all the fragmentation, and we ended up with 72% space utilization. So it did a good job there, except for one problem, which is now we got 10 million blocks on the RM chain. Mm-hmm. So we have a long RM chain. And that happens in real life too. I've seen lots of long RM chains. So what happens because of that then is as you're adding more records to this table, the RM chain gets used to find empty space. So we're finding empty space all over the place, which leads to scatter. So we have, after a while, you add more records to this database than the index and the row IDs don't match anymore.
So you need to run table reorg again.
Right.
Kind of like a consultant.
On the other hand, if you reorg this database again, after having just done it, then it doesn't do anything. It And it doesn't take very long to tell you that it didn't do anything. Also, something I want to point out, you can see here the command line that I used, table reorg account recs, 100,000. That 100,000 is how many records per transaction to move. And the reason I made it 100,000 instead of 1,000, as in the earlier ones, is because I got tired of watching all these messages scroll by. So I made the transactions bigger just so there'd be fewer messages.
And last year we discovered that transaction size had no impact on the speed of this.
Yeah. There's actually a command line parameter to control the messages a different way that has nothing to do with the transaction size. But this was easy. I didn't have to go look that up. But that's why I changed from 1,000 to 100,000. All right, Mike's turn.
Okay. So trying to make this a little bit more real world, even though it's still the ATM database.
So I get to be the eye candy now.
That's right. So we introduced another machine as an OE replication target. Because last year when you did this, it was just bare, no after imaging, no OE replication. That's not how anybody runs a production system. Because everybody's here running after imaging, right? How many are running OE replication? A handful. Okay. So we introduced a smaller machine. That's not the way you're supposed to do this. Your replica machine is supposed to be the same size as your production machine because the whole point of that is to fail over to it. But we weren't ever going to fail over to it. We were just using this as the replica. They're on the same network, so we had to enable after imaging, or AI. There. I am now AI compliant. I have AI in a slide. So we're 2024. I'm good. And we enabled OE replication. So here are the scenarios. Run the ATM benchmark by itself, but it's a modified ATM benchmark because they added some readers. I changed the benchmark from the default 150 users to only 15 users because I wanted to have some headroom because I was going to be doing things in parallel because I don't think anybody runs their system so their CPU is 100% utilized, I hope. So usually people run the system so there's some overhead available, right? Then we're going to run table reorg by itself on a larger database, and then table reorg with the modified ATM in parallel and see how that affected each one of these processes. Then I'm going to talk about table partitioning in move. So I'll describe how that's set up and how you can do that with the 4GL to basically manually do a dump and load while the system is running. And that's Patrice is the one that came up with this. I've demonstrated this a couple times, and I did some benchmarking with that. So I do that by itself. Do that with the modified ATM, and then I tinkered with it a little bit because it is a 4GL. You can adjust things. You have a little bit more flexibility. And then finally, dump, load, index, rebuild, rebaseline, and see the timings on all this. So what's the system? So last year, how many were in the bunker last year that saw what we were doing? So there's a lot that we're not. So let me describe the two scenarios that I had last year. One scenario was build the ATM benchmark. This one, I'll describe this one, the easier way. So I built it with the account numbers being negative. So the first account would be -1, -2, -3. And then that process finished, and that had 500 million rows. Then I loaded again with the account numbers in ascending order, starting from 1, so 1 to 500 million. After that, I deleted the negative numbers. So now I have this big free empty space in the beginning. However, I will admit that I was stupid too and used 4 loaders. So we were not completely sequential, where last year I was describing it as being completely sequential. It was not completely sequential. So that's this scenario that I'm using because I thought this one was more interesting, and I'll tell you why in a second. The second scenario was every other row was deleted. So I'd have account 1, then account -1, account 2, account -2, account 3, account -3, all the way up to 500 million with negatives in between. Then I deleted all the negatives. So now you have account 1, blank space, account 2, blank space, account 3, blank space. So again, that was 4 loaders. They weren't sequentially ordered. That's probably not the more typical scenario. This I believe, is the more typical scenario because people archive. You have a auditing. You have OpenEdge auditing turned on, and at some point you do the audit archive to pull all the audit records out and delete them. That's what this is going to look like. You're running a audit. You're running something that has a history table or audit table, and then you go delete everything from last year. It's going to look more like this than it's going to look like the interleave deletes.
That will only work if the criteria that you're purging by is sequential in your index order.
Tom's point is that'll only work if the index that you're deleting by is sequential. Most people would probably be deleting by date, which should be pretty sequential. So.
Date would be, but the data may not be ordered that way. You know, account data, transaction data.
Yes, Tom's point is this is not real world. Is that fair?
Yeah.
Okay. So Tom said not real world. It's closer to real world than anything else we got. Okay, and the database is 120 gigabytes. Index rebuild was done to remove all the placeholders that are sitting there for the indexes here. Okay, so pretty clean environment. And so the ATM benchmark, I said, brought it down to 15 users from our default 150 because I wanted to have some headroom on the machine. Plus, I did not know how well that OpenEdge replication machine would keep up since it was a much smaller machine. So 12 of the users are doing updates, 3 of the users are doing readers. And the readers so the updates are simple. Update an account, update a teller, update a branch. So 3 updates and create a history record. The reader is not doing any update. It just finds an account and randomly reads 100 more. And then it reads a teller and a branch, just to get some different activity on the database. So just running this scenario, the TPS I got from this, transactions per second, was about 420. With the longest response time, the longest that any of these transactions had to wait was half a second. That was the longest response time. So we're going to call this the baseline. So this was the ATM with after imaging enabled, OI replication enabled, never hit a peak or high watermark. The replica machine was able to keep up without any problem. So now, let's do table reorg. So nothing else is running on the machine except for table reorg. So table reorg is the only one on the machine. The server's up. OE replication's running. Table reorg took 10 hours and 11 minutes. This is the identical database from last year. On the identical hardware from last year, the only thing that happened is things got older because we're now a year later. So the last bunker, this took 8 hours and 40 minutes when it didn't have after imaging or replication. So that's the cost of after imaging and replication. I didn't work hard to tune this. I might have been able to make this go faster, but I don't think it would be significantly faster. Good? Okay. So in doing this, I'm like, do I need to re-baseline the OE replication every single time? It's like, this is going to be a pain if I have to do that and run all these tests. Because I have the backup on the source machine that has repl target create, because I needed that to go create the target database. I copied it to the other machine, so I have that same backup with repl target create. I should be able to restore them both. Should be able to enable replication and start things up. Do you think it worked? No. Started up, and I get on the target 3105. Very descriptive. I have to go look that up. That says transition status. I have no idea what that means either, but it's better than 3105. And on the source, I have 1199. It says it's inactive. So I'm like, oh, you got to be kidding me. So I'm going to have to go delete these, recopy things over, reback it up. That was my issue. Reback it up with repl target create, and then recopy it over, restore them, and go from scratch.
Did you have fun?
No, it wasn't fun because I didn't do it. I shut down both databases, and I remembered something about this atm.repl recovery file. So when you're restoring a backup to a target, you need to remove the atm.repl recovery file. I don't know why. You think the system should be smart enough to do that, but it's not. So I removed that from both target and source, and replication worked. So that was my aha moment for this going. It got me so I didn't have to have more fun, which was good. Okay, so now we're doing the table reorg in the ATM together, because this is going to try to mimic what you guys would be doing. Maybe not during the day, but during night, during batch processing or whatever. What would that look like? So table reorg now took 24 hours and 19 minutes, so it basically doubled in time to get its work done. And the ATM results cut in half. Instead of 420 transactions per second, it was 240 transactions per second, with the longest response time being almost a minute. Now, that response time of almost a minute wasn't all the transactions, but it was a significant number to be able to drop the rate in half. So that's all I could do.
And it is not fun to be the guy who's waiting 90 seconds after he hit the enter key.
Right. So that's all I could do here. There's not really much adjustment to be made to table reorg or to the ATM, because the ATM is the application. We're not going to adjust the application so table reorg can run better. Maybe I could do something to make table reorg not be so aggressive, but right now there's nothing in table reorg to make it be less aggressive, other than I change the scope of what it's doing, but it's still going to do it as fast as it can. And when it's doing it as fast as it can, you're going to have this type of impact on your system. So let's try the table partitioning move technology. Again, Patrice right here. Raise your hand, Patrice. Patrice invented this. I'm not taking any credit for this, even though Dimitri tried to give me credit today, and I said, no, it was Patrice that did this. So enable table partitioning, add a field to the account table. The field I added was my area, which is important for the next slide. And then add a non-unique index, I area, and then I index rebuild. I wasn't going to hurt myself to add this stuff. So I index rebuilded so everything's good. The partition was set up so when the value was 0, which is the default, it would reside in the account area, which is the area that it existed in. And when the value is 1, that my area field, when the value becomes 1, it moves from the account area to the account 1 area. How do you do this? Enable table partitioning on the database. Well, you got to go create account area 1 as well, but enable table partitioning on the database, and then you can use SQL and use the SQL statement, the SQL string here, to do what I just said. So set the schema to pub, alter the table pub accounts. So I note that that's the table. Partition list by my area. I wanted to make sure people knew that my area was the field that I added. So you got to get rid of these, notes when you do it. And then when it's in the account area, the partition initial value is 0, and it's going to be in the account area using the index I area. And alter the table now and say add partition account 1. Values of 1 will go into the account 1 area. This account 1 and that account 1 don't need to be the same. This could be foo and storage area account 1. That storage area, what you're putting there has to match the storage area. Do this, and now you have table partitioning in place, and now you can then set the value of my area to 1, and all of a sudden that row is going to be deleted from the account area and copied over to the account 1 area. How do you do that? This was simple. I was displaying to the screen, you don't need to pause 0 before hide, but for each account exclusive lock, if I'm already 1, don't do anything, assign it to 1. I equals I plus 1, just have a counter, and then I was or maybe I was displaying to the screen so I could just see what was going on. And this goes, and at the end it'll tell me how long it went. So it's very simple 4GL, and the table partitioning setup is pretty straightforward.
Yeah. One comment. Note that Mike used a SQL statement to set up the table partitioning. There's other ways to do it, but that's the easiest.
I just copied what you did.
I know.
Okay, so how long did that take? This was the table move standalone. Took 17 hours, 23 minutes, and 20 seconds to do the move, going as fast as it could. Yeah.
You could maybe increase the performance with the batching the transactions.
Batching the transactions here, maybe. We got to be careful about that, though, because I'm going to come back to last year's presentation, because I thought about that, and then last year's presentation, I batched the deletes, and because there's a unique index, eventually every time it went through the 10,000 rows in the batch, it had to go and skip over all the delete placeholders. So I got 500 million of these, and eventually it spent all its time doing nothing but finding where the next index was, because it broke out of that for each, so it had a for each again. And then it spent a lot of time with index delete placeholders. So I said, we're doing a move which is going to do a delete on account 1, a delete on account and a create on account 1. I figured that the index delete placeholders would get me in trouble again. So I thought about that, but I chose not to do it.
Yeah, so it got slower and slower and put a bigger and bigger load on the index.
Right. So 17 hours, 23 minutes, 20 seconds. Add the ATM to it, and that 17 hours went to 40 hours and 45 minutes. The ATM results dropped to 193 compared to the 420. And remember, when we did table petitioning, I think we were at 240. So less than the table petitioning results, and the longest response time was 9.4 seconds. Again, small percentage of the transactions had this wait time, but if it was me, I'd be pretty mad, right? Still waiting 10 seconds, never mind the 59 seconds from before. So what can we do? Let's add some sleep. It's just the 4GL, right? So you can add some sleep time. So I didn't know what I was doing. I just said 200 records. Let's do a half-second sleep every 200 records. Let's see what that does, right? So I did that. Seemed to make sense, except the time to move all the records moved out to 18 days. Probably not the approach you wanted to have, right? But the ATM results went up to 339, and the longest response time went down. So good things are happening, but the table move was taking way too long. So let's do some analysis. So when I was doing the table move, the table petition move by itself, it could do 8,000 records per second. So when I put every 200 records move, sleep half a second, that dropped the rate down to 240 per second, because the majority of the time I'm sleeping now. So I said, well, we're sleeping too long and we're doing it too often. So what if I said, if I could do 8,000 records per second, why didn't I every second sleep for a quarter second? Just making this stuff up, right? So that got us down from 18 days to 51 hours, which is not that bad. Still, a couple days, and you can stop this and restart it whenever you want. Not that bad, and the ATM results didn't really change. So 340 transactions per second, but our longest response time went back to the ATM by itself. So putting that sleep time in the way I did had very little impact on the application, except that the transaction rate went down. So to summarize, so I gave you a lot of data here, so let's summarize what they have. So ATM by itself is 420, right? Table reorg by itself is 10 hours. ATM and table reorg brought the table reorg to 24 hours and dropped the transactions per second in half. So that's beating up the system. Table petitioning took 17 hours. Putting the ATM and table petitioning together dropped the TPS down to 193. So that's not really the best approach. Putting some sleep time in was too much, 18 days, but the TPS went up, so it wasn't having a huge effect on the application. Adjusting this, which I only adjusted once, you could probably fine-tune this a little bit. 8,000 rows, 4 second sleep. Yeah, the move takes a while, but the application's really not impacted too dramatically. So that's the summary here. And this is all with after imaging and replication going the entire time. Somebody's going to ask the question, how was Pika? I think I already said Pika kept up the entire time, never even moved the high watermark of Pika, so that machine was able to keep up. So let's talk about the dump, load, rebaseline. So the dump of this database took 27 minutes, load took 95 minutes, index rebuild about 20 minutes. So a total dump and reload time of 2 hours and 22 minutes. How about the copy? So we had to back it up after we did this. We had to copy it to the target and restore it. And so 20 minutes, 30 minutes, 40 minutes for a total of LAN time of 90 minutes. Add the dump and load time in there, and you have a grand total of LAN of 3 hours and 52 minutes with the ATM TPS of 0. Because there's all downtime, you can't be running your application at this time. So how much money are you losing for this 3 hours, 52 minutes is really the question. I copied across a WAN. I didn't do everything else. I just said, well, I'll just copy this from Gus's machine at his house down in North Carolina to my Mac that was sitting in New Hampshire. And that copy took 3 hours, 21 minutes, so that across the WAN was increasing the time to rebaseline or replication. So then I said, well, I'm sitting here, and I'm going to try to copy it here from North Carolina to my Mac here. And I did it when the network wasn't really great, and it was going to take days. But I did it earlier today, and I got it down to about 30 hours. I didn't let it complete, but the estimate of the SCP was 30 hours to go from North Carolina to here. The speed of our network doing a speed test was about 8 megabits per second, so not really a fast network. So I don't know if you had a really fast network connection here out to the internet, if you could get it back down to the 3 hours or 5 hours to come across the Atlantic. Okay. You're no longer eye candy, we're at summary. So that's what we did. So Gus talked about how table reorg worked in his smaller examples. I brought it into a larger database, OE replication, an application, after imaging, trying to make it a little bit more real life and doing multiple methods. So what did we learn? Don't believe Gus. That's the first thing, right?
Right.
Because he's embarrassed. Table reorg is fast and useful to remove it. And the data, one thing I need to call out, I called it out here. So table reorg is fast and useful, but it's going to increase the size. There's no doubt about that. And it's going to have significant performance impact, and you have no control over what that performance impact is, other than narrowing the scope of it so that impact's not so long. So you can do a section, and then another section, and then another section. But during that scope, it's going to go as fast as it can, and it's going to really impact a running system. So it should be run off hours. The table partitioning move is very useful. Anybody running table partitioning? Anybody have the table partitioning license? So the license, if you have advanced OpenEdge Enterprise, the advanced Enterprise edition, you'd get the table partitioning bits, and you could go do this. Last year, I did a presentation with Vladimir, and he was at a logistics customer, and he did this live on their system. So he did this table partitioning move on a couple databases, on a couple tables in a database that were not super large tables, but they were really fragmented, and we did the move while they were in production, and their performance went up 40% after the move was done. So it is a useful tool. It takes longer, but you have control over the speed. And keep in mind, it's going to double your area size because the area that you're moving from is still there. It's not going away. So that you have 120 gigabytes that you're moving from. You got 120 gigabytes that you moved to, And that 120 gigabytes is still part of the database, so your backups are going to be bigger.
Yeah, but disk space is cheap,
Disk space is cheap, yes.
and you can always truncate the area.
And yes, you could. Not without disabling after imaging and rebaselining or replication. So if you can tolerate the downtime, traditional dump and load still wins. We're talking 10 hours at best with nothing going on in the system, and compared to 2.5 hours with a traditional dump and load and rebaseline. And as always, test anything you're doing before you go into production.
Yeah, particularly if you're using table reorg, you got to pay attention to, do you have enough disk space?
Right. Questions? Are we done? Yeah, we're done.
So when you do table reorg or table partitioning compared to dump and load, you're still transactional based. Your database is intact.
Can you say that one more time, please?
If you do table reorg or table partitioning, you're transaction based. So your database is still intact. When you do a dump and load, you can kind of fuck up. I mean, if you don't get the proper load.
I'm still not understanding. So you do the table reorg or table partition move.
Your database is still intact.
Your database is still intact. You bring up a good point. Your database is intact. I'll tell you this: dumping and loading a database is getting more and more complex every single release, because you enable features that you have to remember to re-enable. Large files. Do you have CDC policies in there? Do you have table partitioning policies in there? So the safest way to do this would be dump, truncate, load. That keeps all your users, all your SQL permissions, and all those other things intact, because you're not really deleting the database. You dump the database, you truncate the areas, you load the database, you index rebuild, and that keeps the database pretty intact. Yeah.
If you do table reorg and you have it crash or you have to stop it, what will happen when you bring it up again?
So the question is, with table reorg, what happens if the database crashes during it, or you have to stop it? You can pro-shut-c list or hit Control-C on the screen. It is recoverable because it's running with after imaging and OE replication, so it's a recoverable process, just like any other process. So it'll just when it starts up, it'll start up and it's going to scan to the point that it got to, and then it's going to continue from there.
Yeah, so it figures out where it was and then continues from that point.
And
Still just bring up the system and it will work.
Yeah,
bring it up and it'll work. So this brings up a point of just any utility or any process. If after imaging is enabled, and you can do that with after imaging is enabled, it's recoverable. If there's a process that you need to do, for the most part, if you have to turn after imaging off to do that process, and you crash in the middle, it's most likely not recoverable. A good example would be index rebuild. Index rebuild forces you to turn off after imaging, and then if you do an index rebuild and it fails in the middle of it, you have to restore backup. Or you have to restart that index rebuild. It's not going to remember where it was, and it's going to start back from the beginning. So it's not recoverable. But when after imaging is turned on, and can be turned on during their operation, whatever that operation is, it's going to be a recoverable operation. Other questions? Yes, Tom.
So you were mentioning about the napping in the 4GL example. There is an enhancement request in the IDEOS portal to add a nap parameter to that utility.
To table reorg. Yes. So Tom's point is vote up the nap on table reorg if you think you're going to use table reorg, because that would be very useful. If you could put a nap in table reorg so it wouldn't beat up the system so much, then you could run it. It would take longer. Do it in segments, it would take longer, but you could still run your application. It's not something that has to be done overnight. You're dumping and loading a database, and the table reorg can do a quarter of it, a tenth of it, a fifth of it, and just do it consecutive nights during off-peak hours if it could be run, if the application could tolerate it being run. And right now, that's tough because of how it just wants to get done as fast as possible. And that's probably not the way.
Yeah, the
we need to think
performance
about it.
impact is horrendous.
Right. So if we can remove the performance impact and it takes 10 times longer, who cares? Right? Because you can stop it and start it, stop it and start it. So that's a great performance enhancement in the portal. So if you are interested in using this, I would recommend voting that one up. Anything else people want to ask? So got to ask this question. We did this last year. We did this this year. What ideas do you guys have?
What should we do next year?
Right. What do you want us to test? You don't have to say it out loud, but we're here for the next couple days. Come find us and say, have you ever tried this? And we'll be like, maybe we'll try it.
Yeah.
Okay? Okay. Thanks, everyone.